Previously, we saw how to calculate a scale factor using information about a diagram in real life lengths or distances. Now what we'll do is use a known scale factor to calculate one of those diagram or real life lengths or distances. To do this, we're actually going to use the same technique that we used for our previous unit conversions, which is multiplying what we have by what we want over what we have in order to get what we want. The difference is that before, this fraction came from our unit conversion table, but this time what we're going to do is use our scale factor as the fraction. So for example, houses in a subdivision are drawn at a 1 to 200 scale. If the garage measures 1.9 centimeters on the drawing, how large is it in real life? So here we're told that this distance on the diagram or drawing, I'm going to use diagram so that we're using the same language each time. Diagram is equal to 1.9 centimeters. We want to know how large is this in real life. Well, so we're going to do the have times want over have. And that's going to equal what we want. But this time, instead of thinking about units, we have to think about diagram and real life information. So what we have is information about the diagram. And so we're going to be multiplying that by a fraction of real to diagram to get the real life in meters distance. So what that does is it's going to basically cancel our diagram lengths and leave us with the real length. So our diagram length is 1.9 centimeters, and we're multiplying that by the ratio of real to diagram, and so as a fraction. So our ratio always goes diagram to real. So the real is 200 and the diagram is 1. So 1.9 times 200 is 380 centimeters. And if we just stop here to think about what we've done, we've taken a small distance from a diagram, 1.9 centimeters, and multiplied that by 200 to make it much larger, equal to 380 centimeters. And in the context of this problem, that should make a lot of sense, because we're trying to figure out the real life distance or real life length, width of a garage. So now we know that the garage in real life is 380 centimeters, only we want to turn that into meters because that's what we were told to do in the problem. So now we're going to do a unit conversion of 380 centimeters times centimeters into meters, and there's 1 meter for every 100 centimeters, and that's equal to 3.8 meters. So there is our real life distance or width of the garage, which we got from a measurement on a scale diagram and a scale factor. Let's do one more example. Ben is an art student at Camosun College, and for his end-of-term project, he would like to carve a 1:8 scale replica of the Kwakwaka'wakw pole outside the Royal BC Museum in Victoria. This is in Thunderbird Park, just outside the museum. So he measures the pole to be 22.5 feet tall in real life, and he needs to figure out how tall his replica is going to be if he wants to build it to that scale. And we want to figure that out in centimeters. So we're going to start by figuring out what we have and how we're going to get what we want. So what we have is a real life distance. So we have the real life distance. So we need to multiply by a fraction using our scale factor with the real life on the bottom and the diagram length on the top, and that's going to get us the diagram, or in this case, the replica model length. So the real life distance is 22.5 feet, and we're going to multiply that by, well, we have to use our ratio. And again, our ratio always goes diagram to real. So if we want diagram on top, that's 1, and real on the bottom, that's 8. So we have 22.5 times 1 over 8. That's the same as 22.5 divided by 8. So I'm going to do that in my calculator, and I get 2.8125 feet. This is the height of the replica. But this is the height in feet, and Ben needs to know how high it is in centimeters. So we're going to have to turn this into centimeters. Luckily, that's a one-step unit conversion. If we go to our table, we have a feet to centimeter relationship. So we're going to go 2.8125 feet times from feet into centimeters, and for every 1 foot, we're told there's about 30.48 centimeters. So 2.81 times 30.48, and I'm going to use all the decimals. That's 85.725 centimeters. And so if we want to round for Ben's case, that's going to be 85.7 centimeters, or you could round it to 86 centimeters. That would be reasonable too.